What is up everyone, Rex here, and this is our part 2 video of VFX work cycles. In this video we're going to extensively work on animating and simulating our 2D mesh in the 3D world. So without any further ado, let's get into it. So firstly, here we are in Blender where we last left off. After motion tracking, we extracted our object location and camera rotation. Basically we have two nulls named copy location, which is our object location, and copy rotation, which is our camera rotation. Now what you need to do is that you're gonna go in mesh, single word, and add single word. Perfect. I'm just gonna hide both of those nulls there. Now I'm gonna go to the constraint tab of the single word and add a copy location. Set the target to copy location. Now get a cube and a cube only, don't use anything else, and give it a copy rotation. Now set the target to copy rotation. Perfect. Let's call it rotation data. Now you need to export your location and rotation data in the form of an Alembic file. So I'm just gonna go export Alembic. I'm gonna call this location data and I'm gonna make sure only selected objects is checked. Do the same with your rotation data. Now here we are in Houdini where we last left off. Add a math size node and set justify X to none and justify Z to none. Set justify Y to min. Also go back to your trace node and enable add point texture. Now finally get a file cache node and let's cache out our animation. Now if I play it, perfect, this is exactly what we want. We have converted our video into a 2D mesh. Now get a null, let's call it track object. And the geometry node that's containing our track object, let's call it track. Now get another geometry node. Now for the terrain I'm just gonna get a grid, say it's a 10 by 10 grid. I'm gonna give it quite some geometry, about 1 million polygons. Then I'm gonna add a mountain node. You can see we have an uneven terrain. I'm gonna change it a little. Maybe I can increase the amplitude to 1 and element size to maybe like 4. Okay, that's a little too soft. Maybe 3 would do the trick. Okay, that's good. Now finally get another null and let's call it ground. Now get a third geometry node. Let's call it animation. Now this is the backbone of our node systems. Firstly, I'm gonna get an add node and add a point. I'm gonna set the point to 0, 100, 0. Get an attribute wrangle and we're gonna define the normals of this point as 0, -1, 0. Perfect. Now as you can see, our normals are pointing downwards. Now I'm gonna get a ray node. Connect the first input with our attribute wrangle. Now I'm gonna get an object merge and bring in our ground. If I add a transform node after add, and if I move it in Z or X axis, you can see that our object is moving on the terrain. Finally get an attribute delete and delete the normals. We don't need that anymore. You might wanna make one of these. I don't know what they're called, but I do know what they do. Get a polyframe node and set the tangent to tan and bitangent to up. Now if I get an attribute transfer, I'm gonna plug in the attribute delete in the first node and the polyframe node in the second node. Now I'm gonna transfer the tan and up attribute. Now let's get another attribute wrangle. Let's paste in this code. All codes are linked in the description. Finally get a copy to point. Plug the attribute wrangle in the right input. I'm gonna get an object merge. I'm gonna plug that in the left input and we're gonna import our track object. Perfect. So as you can see, this is our original animated object and this is our object after we have aligned it with the ground. Now here's the thing. If you want to move our object along a terrain, we're going to move the point, and if you want to rotate our object around the terrain, we're going to rotate our track object. But here's the deal. The orient attribute isn't transferred to the copied mesh, and even if I use an attribute transfer to copy it, it's simply copying the orientation of the point and is not considering the rotation of the object. So we need to fix that. First of all, let's go to output attribute of our transform node and select xform. Xform is a detail attribute which preserves your transform information. So we can extract that attribute, use an attribute wrangle, set it to detail and paste in this code. Again, linked in the description. Now let's get another attribute wrangle and paste it here. Now paste in this code and let it set to points. And as you can see, we have extracted our information from the xform and converted it to an orient attribute. Now the problem is the copy to points is simply transferring the object orient and not the point orient. We need to find a way so that we can integrate both point orient and object orient into one another. And we can do that by multiplying. Click on copy to points node and in the multiplying section, enable orient. Perfect. Now our point orient and object orient are multiplied and are correct. Now expand this section and remove the orient attribute from the copying tab. Perfect. Now get an attribute delete and delete all the unnecessary attributes like tan. Now place an attribute wrangle and we're gonna extract tan and up from the orient attribute. Why are we preserving the orient attribute and why are we extracting tan and up from it? That's a topic of the next video, but for now just trust me. Alright, so now we visualize tan and up. Perfect, this is exactly what we want. Now virtually we are done because we are using a 2D mesh, but if you're using a 3D mesh and moving that on an uneven terrain, you need to do the following steps. Get a connectivity node, set it to primitive, an attribute to class. Now get a for each primitive, put that here, get an attribute wrangle, get your ground object and plug it in the second import. Perfect. Now make sure the piece attribute on for each end is class. If I enable it now, and you need to paste this code in the attribute wrangle. Now to visualize what we are trying to do here, if we use a 3D object like this test geometry, you can see that some parts of our test geometry are below the ground. We don't want that. After activating this, you can see all of it is above the ground. This is what this code does, alright? But since we are not working with a 3D object, we are only using a 2D object, we're not gonna need this. Now get a group node, set it to points and leave it as it is. Why? Well, it's a topic for the next video. Finally get a null and we'll call it animated object. Basically, if you are making manual changes in the movement of our object, you need to add a transform node after our add node and a transform node after our object merge, which imports our tracked object. The first transform would be used to move the object, whereas the second transform would be used to rotate the object. Now to change our location, we're going to go in our first transform and we're going to keyframe the translate value. And maybe at about 211, I want this to go to 0. So the initial value is 4.5 and the last value is 2. So as you can see, our object is moving on the terrain, but it's trembling a lot. That is because we have a very detailed geometry with a lot of roughness. If we can reduce the roughness by going into our mountain node, you see the trembling stops. It's moving without trembling. But that's not realistically the case for everyone. Maybe you need a rough terrain. So I'm gonna show a workaround for that. Basically, let's restore our roughness and after the polyframe node, add an attribute blur. Now select tan and up. Basically what attribute blur does, not the best visualization, but it changes these attributes to these. It kind of smooths out the tan and up. Now if you can see, I'm going to set the influence type to proximity radius to 1 and blurring iterations to 75. You need to find a sweet spot. Now if I move our mesh, it's not trembling, but you do kind of lose a bit of precision here. So again, find a Goldilocks zone which fits you the best. Now, the original data that we had, that we imported, now we're going to import our tracked location data, which we imported from Blender. And let me just disable all of these. If I go in here, you can't see anything, but it's there. If I see this, you can see there's 1 point. Now do the same for our rotation data. And as you can see, our cube is here. Finally, how do we transfer this to our mesh? We're gonna write another wrangle and we're gonna get an object merge and we're gonna import our location data. We're gonna plug that into input 1 of the attribute wrangle. Now I'm gonna duplicate that attribute wrangle and place it again after attribute delete. Perfect. Paste this code in the first wrangle and paste this code in the second wrangle. This is if you have some jumps in your scene when you want to move above the base mesh. Let's get an attribute wrangle inside the solver. First input would be input 1 and second input would be previous frame, and paste in this code. And you want to click this little icon here to create custom parameters. We'll come back to this later. Now to copy our rotation data, we're going to add a copy to points after our object merge. This is the object merge which imports our tracked object. I'm going to duplicate that object merge and I'm going to import our rotation data. Firstly, let's unpack the alembic because that's what it does. and add an attribute triangle after it. We're gonna add in this code, and as you can see we have 4 variants of our mesh. We're gonna fix that by adding a pack node, and we're gonna transfer the orient attribute. And as you can see, our object goes immediately flat. And the reason why that is happening because our rotation data is also flat. So I'm just gonna get a transform node and I'm gonna manipulate this rotation data. If I set it to -90, 90, and in the y-axis rotation I'm gonna add $F. Now if you visualize this, the object is rotating with the rotation of the cube. I have not done anything to the object, it's the cube rotating, and that rotation data is being transferred to our object. Now below our copy to points there exist these 3 items. You want to select them and bring them above the left input of the copy to points. Finally go into the copy to points, delete the orient attribute from copying and transfer it into the multiplying section. Perfect. Now I am in Premiere, just gonna make this a little bigger. Let's play. So I walk for about 8 seconds. Then we're gonna go back to our location control transform and keyframe the value from -4.5 to 0. As you can see, I am moving on the mesh. You can change this to linear if you want. And perfect, this is exactly what we want. Now from about frame 9, my camera kind of moves in clockwise direction. So that's what I'm gonna do with our object. I'm gonna rotate my object in clockwise direction. If through proper tracking you have object location and camera rotation, it's perfect. You don't need to manually keyframe anything now. But if you want to manually change the rotation and location of the object, or from scratch you want to manually move and rotate the object, you need to keyframe. Again, the first transform deals with location, which is below our point, and the second transform deals with our rotation, which is below our object merge, which contains our tracked object. Finally, if you have jumps in your sequence or anything in which you move above the base mesh and then return to ground, you're gonna have to use a solver. So what we're gonna do is that we're gonna get a third transform node. We're gonna place it after the attribute transfer, and this time, and I'm gonna go to frame 645 where the jump starts. Alright, and this time I'm gonna keyframe the y value. Now if you've studied physics in high school, remember back when you were smart before you decided to choose 3D art as a career? Or if you just have common sense, you know that jumps occur somewhat like this. You are at base, you reach the top, and then you come back again. So basically my jump starts from frame 645 and ends at 680. So both of those values are going to be keyframed to 0. Now somewhere in between I reach the peak height. So the middle frame would be 657. And there I'm gonna add the value of translate as 0.1. But the problem doesn't end and you need to use a solver node. Why? Since when we jump we generally don't align with the ground, the orient attribute, which basically determines the rotation of our object, is being determined on the basis of tan and up from the ground. The problem is that our third transform is after the attribute transfer. Basically when you jump, you just jump straight ahead, you don't align with the ground. But since our third transform is after the attribute transfer, the orient attribute which is being calculated is still aligning with the ground. And therefore we need to freeze the orient attribute from the point you start the jump to the point you end it, and then we need to add a smooth transition to blend from the frozen orient to the new orient of the ground. So for that we're going to use a solver node. I'm going to go in solver. We have already created this custom parameters. Alright, so the start frame would be where your jump starts, so for me it's 645. End frame would be where your jump ends, for me it's 680. Blend frames is the amount of frames the transition is going to be of. So I'm just gonna write 40. Perfect. Now if I reload it, go to frame 645, reset the simulation. Now if I play the simulation, you see our object remains same and then it slowly aligns with the mesh. You see, that's the problem we solved. Well, that's it for this video. But Rex, how am I gonna render this? It's a 2D mesh in a 3D world. One dimension is missing. Well, that's a topic for the next video. I'm gonna teach you a way that you can parent your camera with the object in such a manner that the illusion never breaks. Well, that's a topic for the next video. And I'll see you there. Bye bye.